So it's my pleasure to introduce Richard Baraniuk from Rice University, who was just here a couple weeks ago for another conference, who's really been an innovator alongside his innovative science, has been an innovator in the world of open textbooks. So we're interested to hear what you have to say. Here is your clicker.
Thank you. Okay, great to be here. Thanks so much for the invite. It's great to be back at Stanford. And to see so many friends in the audience actually increases the stress level considerably when there's friends. So I did some homework about cores and your absolutely fantastic mission. And so what I'd like to do today is just talk a little bit about my sort of history, trials and tribulations in the area of education, and talk about how openness has so often been the answer to problems that I've faced, challenges I've faced, and how I really believe that openness can and really should be the answer for so many problems that we face today and that we're going to face in the future. So hopefully you'll see lots of resonance with the core's mission. I have to be very fast because I have to finish at about 1:30. I see I get 3 bonus minutes because we started early. And so we're going to go lightning fast. Still, feel free to interrupt me with any questions. And I'm just so lucky to have Chris and Angela talking after me who can right any wrongs that I make around both AI and education. Okay? So let's go? Okay. So let's just take you were talking a little bit about OER, Genesis, people thinking about this. Let's go way back to me back in 1999. I was teaching, I had a lot more hair then. I was teaching an intro electrical engineering course. I loved it. I thought it was just absolutely amazing material. Fourier analysis, show of hands. Super fantastic information. But I was dealing with this. Okay, anybody dealt with this? Okay, and so I started experimenting with new kinds of teaching techniques, all kinds of different ideas, and they started working, right? And so I ended up similarly having this itch of like, maybe I should write a textbook, right? Because that was really the way that educational ideas were transmitted, right? Back in 1999, it was to write a paper textbook. So I took a look around in my area of signal processing, and what I saw was a world that was like ripe for like commoditization, okay? Not a new book, but some new idea, okay? This is all the competing books in the market. Everyone has a mountain on the cover, if you haven't noticed, okay? Everyone has the same table of contents. I wouldn't do anything new, okay? And so it just so happened at the time, 1999, the internet was happening, right? And we were thinking about web pages and how you could like disaggregate content in different ways. So the idea was very simple. Instead of writing 1,200 pages, right, that are linearized, printed on paper, bound together into a book, why not rip those pages out, put them into web pages, have a database, right? Have hyperlinks so everything could be reworked, reorganized in all kinds of different ways to build different kinds of, I'm an engineer, learning machines, right? That could be right for my course, but then other folks could innovate on them for their course. And then how about we use a community to generate a lot of this content and then make everything free. So rethink the IP from proprietary content to open source licensed content, okay? And you also talking about Stanford, Larry Lessig and the Creative Commons, just absolutely critical in this space starting in like the early 2000s, okay? The other thing that I was really hoping of being able to build these different learning machines is that every kid could have their own learning machine, because that's what I found worked in my courses, that there were we were studying Fourier analysis, but there were the digital photographers who wanted a completely different way of thinking about that same idea, the same formula, as the digital music people or the digital communication people. So personalization just became something lodged deep into my brain. So let's fast forward, 2012, about 13 years later. We'd been chugging along. The project we started was called Connections, and we had thousands of authors writing hundreds of thousands of these little nuggets. And then we realized that there was another issue, okay, and that was cost. And the sort of flip side of open source is also free, right? The materials not just enabling folks to be able to contribute as a community to content, but maybe reduce the cost of materials. And what we realized back then, and other folks, was this absolutely skyrocketing cost in learning materials, 1,000% growth over 40 years. And so we had this idea, well, why can't we maybe pivot a little bit away from just pure community-generated content to really compete head-to-head with the publishers, right? Compete head-to-head with Pearson, McGraw-Hill, et cetera, who have these outrageously priced textbooks. So we rebranded from Connections to OpenStax, and we basically started raising venture philanthropy to create really high-quality books, but then make them free and open source online, right? So fast forward to roughly today, I can't believe how much we've grown. We just published our 84th book. We cover now basically the entire intro curriculum in any like college or university in the United States and quite a bit of high school. We're now probably the #3 biggest college textbook publisher in this space, right? So many of our books have reached like 50% market share. And it's just really, really interesting to be brought up on like Pearson earnings calls. And the kind of exciting thing about this curve that I showed you earlier, and Angela's going to talk, I'm sure, more about this later, is that there has actually been a stabilization, right? A disruption in this space that we've actually, us and a number of other OER providers have been able to really stabilize the cost of textbooks. And you can think of it kind of like a Southwest Airlines effect, right? Any educational market that OER flies into, right, the incumbents have to lower their prices in order to compete, right? So it's just been a really big win for students. We've saved about $3 billion for them over the last 13 years or so. Okay, so that sounds great. Thumbs up, maybe, right? Wow. Okay, would I love to have that guy back? Okay, but here we are in 2025, and the world is continuing to spin, right? And we are moving from an access crisis, right, that we've just been talking about, to an attention crisis. Any faculty instructors here notice? Okay, nobody reads anymore. Does anybody notice this? Okay, nobody reads, and the students that do read do it in an entirely different way. Habits are changing just rapidly. And if you think in terms of sort of like a plane here with two axes, learning quality and the vertical axis, and time saved, kind of strange, not time, but time saved, going to the right. Well, the world that many of us grew up in, maybe if you're over 40 maybe, was in this upper left quadrant, right? Instructor assigned chapter 7 of the textbook. We actually read it, right? We read chapter 7, then we went and we did the homework, right? Maybe we did it in a group, right? Maybe we went to the library, looked for some other resources. Definitely it took more time, right? Well, what are students today doing? They're taking the homework and they're just typing it into Google, right? I'm not suggesting they're trying to cheat, right? Most students aren't trying to do this. They're trying to make a shortcut because they're very busy. They want to learn as much as they can, as quickly as they can. But what happens when they just go to YouTube to try to find a similar completing the square problem to their completing the square problem is they're not conducting deep learning, right? They're not going through a lot of the productive struggle that's needed to learn. And it results in a fragmented knowledge base in their mind, okay? And so we realize, wait a minute, OpenStax needs to change from this upper left quadrant world, right, to this sort of find a way to an upper right quadrant world. And I would think that this is a space that we're all probably collectively trying to move into, areas where we can use technology, for example, in order to help students learn effectively and help students learn efficiently, quickly, but also really effectively. Okay, and I would say this is a really big, really big open problem, and you can really think of a lot of work that's going on in education today is targeted, in tech for education, is targeted at this. So at OpenStax, we've done a strategic pivot over this last year of moving from thinking of us, as a library or a publisher, to a teaching and learning platform. Okay, so building a platform, it's actually built on top of the campus LMS, where students and instructors are there together, right? So students are actively, they're not just reading from our materials, they're actively engaged in learning from our materials. Instructors are there actively teaching about ideas. And the key idea here is to connect this teaching learning feedback loop, right? To be really efficient and effective for students, but also really help them have deeper learning. And as you might imagine, a really important aspect, right, is AI, a whole host of different AI agents that we're both developing in-house, but also partnering with all the usual folks you could imagine, big AI providers, in order to provide assistance tools, power tools, if you will, right? Instead of having instructors have, hammers and hand saws, right? Give them really powerful power tools in order to help facilitate better learning for their students, and also enable students to have tools so that they can get just-in-time learning opportunities, right, at 2 in the morning, right, when their instructor probably is asleep. Okay, so AI agents, there's just a lot. Chris is going to talk, I know, a lot about this, but there's a lot of promise with AI agents, right? Knowledge integration is one. Some other sort of unexpected ones, right? The fact that folks, people really can get productive experiences by interacting with AI agents, right? You can even fall in love, right, with an AI agent. Okay, not that I would recommend that, right? And so I think that there's just real, opportunity in this space. But we really believe that instructors remain extremely important and central to all of this, which is why we're not just building, an AI-based learning platform, but really a platform that enables us to bring instructors and students and AI agents together. Okay, one of the reasons that we think it's so important to have instructors there is to build trust, right, in these new AI systems, right? I think if you think over the last few years, like last 3 years, there's been a lot of excitement, froth, bubbliness about AI, how it could really impact education. And we've kind of got to a point now, though, where there's a lot of mistrust. Any show of hands, would you agree? There's a lot of mistrust. Students don't feel trusted, right? They're getting turned in by Turnitin, right? Like false alarms on AI detectors, right? And then the students themselves are feeling burnt, right? Because their instructors shouldn't be allowed to use AI tools, right? So it's just a very interesting space that we're in. And I really think it's really important for us to bring these three, the community of instructors together with the community of students around these AI tools so we can really start to figure a way forward that helps build more trust. The last thing I just want to mention, just a little sidelight about instructors, okay? Because a lot of people have predicted the end of instruction as a career, right? A lot of people have said it, yeah, at an end. And I just want to go back to something that I read just recently, which I kind of find really, really fun. So Jeff Hinton, everybody knows Jeff Hinton, one of the godfathers of AI, had this quote. He won the Nobel Prize for AI, so he's Mr. Big, right? We should stop training radiologists. It's just completely obvious, this is in 2016, that within 5 years, deep learning is going to be better than radiologists. Okay? Could you not say the same thing about teachers? Why bother training teachers? I'm just being silly, right? I'm just being sort of speculative. Well, we could train AI. It's going to really help us. Okay? So let's just use the example of radiologists as an example. Okay? So a really interesting article. Okay, what happened at the Mayo Clinic? Okay? They didn't get rid of radiologists. They grew their staff 55%, right, because of AI. Why? Because it was so much incredibly more efficient and effective, right, AI as a tool to augment, right, work as a partner with radiologists as they went through their workday, that it was actually in the best interests, right, of the Mayo Clinic to not just increase the number of radiologists, but build a team, in fact, of like 40 AI experts who continuously build and improve AI tools for these radiologists. And I think we're going to see very similar kind of things in education where, yeah, we can make, hopefully you can kind of connect this. Okay, so not to, right, I've been kind of all excited about AI, boostering about AI. But of course, right, we have to acknowledge that just like the mistrust aspect we just talked about a minute ago, this is a very interesting space in the sense of Confucius, right? And so there's a lot of questions that we need to solve moving forward. But I think, as a community, these are ideas that are challenges that we can surmount. And moreover, these are challenges where I think openness, transparency, reproducibility can go a long way to actually addressing all of these different challenges that we face. No time to go into that right now, but we could I'll be happy to talk about it over the questions. Okay, so now I'd like to, right, we've talked about publishing, we've talked about transforming publishing to teaching and learning platform, at least what we're doing at OpenStax. But the next thing I want to talk about as far as openness is to kind of peer a little bit like under the hood of these AI systems, right, which is the kind of thing that educators don't typically do, right? But since I'm an engineer and I actually work on AI systems in my other half of my job at Rice, I think it's really worth looking at, inside AI systems and what kind of opportunities there are there for open AI. Okay, and I want to be really clear. Okay, I don't mean open AI. Okay, why are they called open AI? I don't get this, but open AI. Okay, very, very. Okay, so the ideas of openness, transparency, etc. Okay, so let's just talk about some quick vignettes, 5 or 6 ways that openness can really, I think the education community can really lead, right? Can really be a leader in this space. So everybody here has used an LLM, large language model, foundation model. Show of hands, just for fun. Okay, gets your metabolism moving. Okay, so you put in a prompt, right? You get out an output that may or may not be useful. Okay, so let's just talk a little bit about this process and about where these LLMs come from. Okay, the first thing is, right, educators are using LLMs to generate all kinds of educational content, educational feedback, right? And the absolute as you know, if you've ever played around, done anything other than write haikus or change chapter 7 into like as though a sailor, right, were saying it, the prompt is critical. You don't have a good prompt, right, for ChatGPT or Gemini, you're going to get like a crappy output, okay? And so the first place where openness can really play a role is opening up the prompts that people are using, right? And so many instructors, right, haven't thought of this. So wait a minute, I could basically put up on my, web page, right, if I'm a college instructor, or my school web page, right? We could start creating a community around generating really high quality prompts for LLMs for different kinds of educational situations. There's a number of reasons why this is useful. It's very time consuming to develop good prompts, so collaboration can help, right? Doing this kind of thing can also help build trust amongst AI providers, instructors, but also students. And the last is the future-proofedness, right? The fact that if you build a really great prompt for ChatGPT, let's say built on GPT-4, and some new fancy AI tool comes out, okay, you would really like to have the prompts that you use for ChatGPT, like GPT-4, archived somewhere so that you can pull them out, right, in order to use them in these new AI tools. And this is all in this. You can think of it encapsulated in this space called open pedagogy. Are you going to talk about it at all, Angela? Okay, this space called open pedagogy, which is really about opening up teaching practices. So this is one place where openness can really help. Let's look a little bit deeper into these AI models and just think about like the models themselves and learning these models, right? Okay, if you don't know how are these models learned, well, an LLM is just a box with a whole bunch of knobs. And as you tune those knobs and you put the same input in, you're going to get different outputs, right? And the way that an LLM learns is by feeding in, let's say it's text data, feeding in enormous amounts of text data, right? And basically playing fill in the blank game, right? And when the LLM is able to, the knob settings are such that you're able to predict what the word in the blank or predict the next word well, then you're going to give positive feedback to these knobs. Otherwise, you're going to give negative feedback, right? So that's sort of 30 seconds on how you tune one of these LLMs, okay? And the critical thing is that most folks in education, right, this is a huge opportunity, I think, for the education space. Most folks are still focused on proprietary models, right, from big tech companies. But there's a real opportunity, right, for the open education community to start using a growing number of open LLMs that are out there. Okay, you may not be so familiar with these, okay? But there are a number. Llama from Meta is a really interesting model. It's got an open architecture. What's that? It just means how the knobs are all put together, okay? Moreover, they actually they trained Llama, in this case, say Llama 4, and they actually gave away the settings of all the knobs. So that's a pretty good set of openness. Okay, that I highly recommend using models like this. Really, though, you should take it to the next level, which is not just to talk about provide as an open, in an open source way, the architecture that you used and how the final settings of the knobs, but the entire procedure that you used to train that LLM. Okay, and this is the kind of program that's being pursued by even more deeply open source projects like Together.ai. It was founded by Stanford buddies of mine, Percy Liang and Chris Ray and some others, right? So this is extremely interesting space around like completely open LLMs. Okay, so highly recommended to think about that. But then there's an even deeper aspect, is where did all of the data come from that you're going to use to train this LLM? Okay, the training data. ImageNet was brought up earlier, right? These methods are trained on essentially the entire internet, right? All the text that these big tech companies can scrape from the internet. And as you know, everybody in this room, I'm sure, knows, this training data landscape is an abject mess, right? Multiple lawsuits flying back and forth, questions about fair use, questions about whether these tech entities should be allowed, right, to train models on, for example, the New York Times, right, or on other large content repositories. And I'll just mention that there's just some really interesting progress in this space that folks might want to check out. And that is, very soon there will be the very first truly open large language model. It's going to be here in the next, it's always just around the corner, weeks, months. So it will be an open architecture model that's trained on a first of its kind open training data set. By that I mean data that is only open educational resources or public domain data or data that has been volunteered, like contributed by certain entities. Right? I think this is really exciting because this is going to enable us to actually basically think about openness in the education world around AI through the entire pipeline from like tech all the way up to prompts. Okay, hopefully that makes some sense. Okay, so just to summarize, by thinking really deeply about openness all the way from training data to model architecture, to the way that we prompt, we can build a community, right, that encompasses not just tech folks, but also educators, also students, public policy folks, and really build a more productive and efficient education AI world. Okay, so hopefully this makes sense. So AI, okay, exciting. Let's rewind back to 1999. And one of the things that we were really hoping to make happen, and that was the idea of personalization, right? The fact that folks learn best when the educational experience is tailored to their particular context, right? And in today's age, we may think, wow, we can we can actually make progress on this now, right? Personalized learning has been a huge dream of folks for like decades and decades. Maybe AI is going to help us, actually build systems that really work. Okay, and I'd say there's still just there's huge opportunity, but huge question marks around implementing or actually realizing this dream of personalized learning using AI. One is, again, where are the training data sets going to come from in order to train these AI systems? And then second, once you build some kind of AI-based intervention, or actually any ed tech intervention, how do you actually figure out if it works or not? Okay, because people are just kind of throwing kind of AI spaghetti on the wall, seeing what sticks, right? So how can we move from that kind of world to a really principled world where we're trying to do like education R&D, right? Where we're trying to gather evidence and use that evidence to both figure out what works and what doesn't work, but then also drive like a feedback loop to the folks who are building these interventions in order to make them better. Right? So do the same kind of thing that happens in so many other spaces, but just really does not happen significantly in education. So what we need to do, right, if we're going to make personalized learning a reality, or if we're going to really understand what works and what doesn't, is we need to like measure, right? We need to take measurements of learning experiences, right? And in education, this was difficult 10 years ago, right? But then COVID happened, digital platforms happened, and today just so much learning, right, happens while students are engaged in a digital platform, which provides just enormous opportunity for like acquiring data, okay? So we need data about human learning. We need really rich data though, not just shallow, what students did on multiple choice assessments. If we're really going to understand learning, which is highly contextual, highly complex, and highly temporal, right? We need to acquire really rich data from learners that are really like, diverse, all kinds of different learners at all kinds of different levels, okay? And we need to obtain data from like lots of learners. If you think of trying to understand the learning human mind, I think that'd be a great example of a very large P statistical problem, right? There's a lot going on inside the mind, right? In order to understand it, the only way to do that is to have big N, right? Very large data sets that we can use, either to analyze what's going on as people learn, or to do things like train like AI engines. And here's where I will actually point to a gap, okay, in the cores, or an interesting opportunity, I guess, that's just so great that we're having this meeting today, right? Because the very first sentence in the core's mission statement on the web page says that nearly every domain of intellectual pursuit is being revolutionized by the availability of large data sets. And it's just so interesting, not so in education, okay? Just totally not so. Okay, so this is something that we've actually been thinking about for a while, about the last 8 years, is how can we build these big data sets? How can we build like an ImageNet for education that has data from large numbers of users, but also has the data being very rich, right? Speaking a lot about their different experiments. And so we basically started stringing together a number of ideas over about the last 8 years or so. So idea one is, well, if folks are increasingly using digital learning platforms, well, we could instrument those platforms, right? So when you're using, let's say, a digital textbook like OpenStax, or a learning management system like Canvas, right? Let's instrument that so that it's not just a learning tool that a student and an instructor go to teach and learn, but it's also a scientific tool, right? Where it's instrumented so data is being acquired, okay? Lots of companies and organizations are already acquiring a lot of this data, okay? Which is a good news, okay? So let's instrument a number of different platforms, and let's not just instrument, like we started with this saying, wouldn't it be great if we had data from OpenStax? But then we realized that we would have just one puzzle piece, right, of the entire student experience. And so we needed to have data from not just OpenStax, but the SIS, the LMS, homework apps, et cetera, right, in order to put together this more complete, rich picture of the student, right? Speaking of putting it together, we need to be able to put those puzzle pieces together so we can think of fusing data from multiple different digital learning platforms, okay? And now, if anybody's feeling kind of scary, is this feeling scary? Okay, this is a massive privacy, there's just massive privacy issues around this. How do we do this in a way that is privacy protecting from the get-go, right? So by design, privacy protection, 100% from by design. And so what we realized is that rather than having data move from digital learning platforms towards researchers or R&D folks, that's very dangerous. Instead, what we would do is we would have researchers' analysis code move to the platforms. Okay? And if you're familiar with this idea, it's called a secure data enclave. This is now becoming really standard in areas like medical data, financial data. And so we had the idea that maybe we should bring this secure data enclave idea to education data for a number of different education platforms. We were very fortunate that after a 4-year proposal process last year, we actually kicked off a very large NSF funded effort to build the national education research infrastructure for the United States that is funded by the same program that funds big telescopes, CERN, et cetera. And I'll just tell you a little bit about it. It's a project called Safe Insights. You can think of it as a sister project to OpenStax. We have 13 big learning platforms, actually 14, but we can't talk about the 14th yet. We'll be able to announce pretty soon. Platforms like OpenStax, Western Governors University, edX, a host of K-12 efforts. These are platforms that are serving about 10 to 20 million students every day. So they have extremely large numbers of high velocity data streams. And then we have, in addition to these digital learning platforms, a number of partners in big data tech, a number of folks here at Stanford actually, and then also in privacy and really importantly in open science, which I think is another thing I think is really resonant with this workshop, that we have taken an open science approach to designing Safe Insights from the get-go. In fact, the Center on Open Science is actually one of our partners. And we think it's really important to do a number of things. First, as might be kind of pretty clear from what I've talked about, we're trying to open up access to large-scale learning data, right? But what we're also trying to do is scale up the community of researchers, right, who conduct learning research, okay, on data of this type. Because it turns out there are folks who are interested in doing data science with different kinds of digital data sets, but the community is like really small, like really too small. And one of our hopes that we're able to have like a 10x or 15x growth in the size of that community, so we have more people, right, all around the country, eventually all around the world, thinking about education problems and how they can be attacked using like large-scale data. Okay, so we're thinking really, really heavily about open science, and I'm just excited that we're going to have an MVP coming soon, and so check back to safeinsights.org often to have a look at the and play around with the MVP. It'll be based on OpenStax, and then we'll be adding a number of these other platforms over the next several years. Okay, so let me wrap up. This has been a frantic pace. I can't believe it's 1:30. So what I hope I've conveyed is that, you know, as we try to, you know, we just have a tremendous opportunity to impact the lives of just a huge number of students in this country and around the world, and students not just at our college campuses, but in our K-12 institutions, students who are not usual students, who are trying to retool or trying to learn new ideas, folks who are trying to make a career change, folks who are trying to gear up for this new tech workforce. And I just really strongly believe that there's just huge opportunity to accelerate, right, the outreach and the impact that we can make in the education world by pursuing openness, not just along one or two of these different open axes, but through all of these axes simultaneously, right? And I think this is a place where the education community can actually move to really the front of the entire R&D world, right? As a set of organizations who are really taking openness to the max. So with that, I will end and happy to answer any questions. Thank you so much again for the invite.
Kia ora. Adam Hyde from, we work in this space, we develop Page.js and a few other things, Kitty. This is really interesting. I'm just wondering though, where does the position of the textbook live in here? You sort of you told a story about textbook starting as being a very successful story in OpenStax, and then the sort of dissolution into various other artifacts. Are we looking at just-in-time development of these educational resources? Are we looking at still a systematic value of textbooks? I mean, how do you see that?
Right, yeah, okay, great question. Probably I was going so fast. Textbooks still very important. When I talk about an OpenStax textbook, it's really two things. One is it's a repository of content, Lego blocks, that can actually be put together in different ways, right? And then it is if we publish, let's say, OpenStax biology, it is then a list of pointers into that repository, right? That then can be sequenced, right, into a sequence of, like into an e-textbook. It could be actually printed, right, as a print textbook. Okay, so but the really important thing is it's kind of the call it like the knowledge base, and then the particular tour, right, that has been through that knowledge base that's been assembled by an editorial team. We still think both are really important. The knowledge base is really important. The tour is really important, but we feel that they're going to be augmented in the future in a number of ways, and you actually already said them. The first, we're going to be building personalized tours, right? You're going to be able to personalize the tour through that knowledge repository, through that content, depending on your context, right? And then the second thing is we're looking really seriously in developing tools around content transformation, which we think is going to be very important. The ideas like taking text content, transforming it into, say, audio or video type content, changing the pedagogical approach of the content, coming at it from a different angle. All of these different techniques are things that we're exploring in-house and also working with partners on. Yeah, that's a really good question.
Hi. So, very exciting. I think the challenge, and I won't even name my department, it's in the medical school because it's a generic question and this applies to everybody, which is the challenge of AI is it could redefine what we expect, what we demand of students to learn, because they can retrieve the information as faster now from AI or better than what's in their own brains. And so AI is not just a challenge to how to, or tool to convey information or transform the educational experience, and I'm sure you've thought a lot about this, but what is reasonable to define that that a student should know? We don't require them to do multiplication anymore because of the technology around computation. So what are your, and this is happening in every field. So what are your thoughts about that even more fundamental transformation of the educational process?
Yeah, this is a great question, and I would say how we're thinking about it is that just to kind of rephrase it in a different way, is that we're moving into a world where the entire mechanisms of assessment have to just completely change, right? So understanding, and so that involves both coming up with like standards, for example. I don't mean tech standards. Standards of, what do we really expect a student coming out of a intro biology class to actually, what do we expect them to have learned, right? And what do we expect them, how do we, what kind of skills do we expect them to have? There's been progress on this over the years, right? Folks saying, well, we should have learning objectives, right, for our content. So I think that work in that kind of space, I think, is headed in a good direction. But I think what we need to really rethink is the whole idea of like assessment as it is done today, right? The idea of what homeworks are, right? The weekly homework, what it is, what the activities are, the quiz, the exam, right? And I think that the really exciting thing is if you think of the flip side of like AI as a tool for for interacting with students, you can also think of AI and like data science tools. I think there's real opportunities for actually having assessment almost like disappear into the system, right? That rather than having students be required to sit down, right, every 4 weeks and take a quiz, right? Actually have assessment just literally built into their course, right? And so they're demonstrating the skills, right, that are on these standards as they go through the course, and like a data science engine is actually tracking that. So I think there's this is a space where we've been thinking a lot, and I think there's a lot of opportunity. Does that kind of help?
Sort of.
Well, here, keep going.
Example, just like coding. If AI, how much do we have to teach them about coding if now AI is an incredibly powerful coding tool, and it definitely annotates better than most coding.
Right. Well, yeah, I just say there's my two answers. The first is some of these spaces are, like coding is a great example, extraordinarily fast moving. So that adds an extra complexity here. But I do think though it comes down to a group of experts sitting down, and I think it's possible to grapple with that. I might not be understanding exactly where you're going, but I think that this is a group of instructors could and folks are sitting down and grappling with what are the ideas that I expect students to have mastered, what are the skills I expect them to have mastered, and then how are we going to expect them to demonstrate that? I think that's something that is actually doable. So hopefully that makes sense.
I had a question about screen time and children, because
Totally.
some people say that, oh, if you're in kindergarten, like the kids shouldn't be having so much screen time. But then it seems like a lot of the data collection that you guys are collecting is, like you would have to sit at a computer and input stuff or read stuff or, look at an iPad or something. So I was curious, like, how do you collect and do the research for kids, and then, how much technology exposure should they have? So that was something.
Great question. Yeah, I just say there's a trade-off, right? That on the one hand, students would be, to get the most data, rich data, and richest data, students would be, chained to their screens, right? Which is terrible, right? On the other hand, there'd be no screens at all, and then it would be we'd be back to basically 1980, right? Situation of very difficult to acquire data, and I think the key thing, we are certainly we're not advocating, right, that we should be way over here at this extreme. The digital learning platforms that we're working with are really trying to understand this spectrum, right? And try to understand really what's best for students. And it's becoming clear that less screen time is often better than more screen time. And that's just, that's a sort of wrinkle, right? That the folks doing the R&D in this measurement space need to grapple with. But I think your point is really well taken, that there's no way we want to live at this extreme. So hopefully that helps.
Hi, thanks for the great talk. I'm Ifan from Stanford HAI. I also worked at Coursera back in
Sure.
2011 when it was first starting. So something that I learned from Coursera was that like giving free content to students isn't necessarily sufficient. Like in the case of Coursera, most of the people who sign up to receive free content don't actually finish the course. So I'm curious, like in your envisioning for like this future in OpenStax and the pedagogical research, like what are there any interventions or tools that you're envisioning that would really help with this?
Okay, that's really helpful. I think that's one of the reasons why. So OpenStax was designed to work not outside of the education world, but actually inside, right? So, instructors can look at one of our books, biology, compare it to OpenStax biology, Campbell biology. They look the same. The only difference is the price tag, right? One is like free, one's $0. And so, consequently, that has enabled us to work and live within this world where students are really valuing. They're getting a real value for the educational experience that we're embedded into, right? Like if Stanford uses one of our books, like say our econ book, well, it's Stanford students, Stanford instructors using our book, and so it's real authentic learning, right? So it's not like MOOC type learning. And when I talk about 7 million students, these are real we call them butts in seats, right, numbers, okay? I think as folks start to move to digital learning platforms that live outside of this space, then your point becomes a really good one, because many folks, most people engage in these kind of platforms in a really shallow way. Maybe to just do some just-in-time, to look at one video, right, for 5 minutes, right, and then jump back to some other place. It's both very hard to try to help that student in the time, and it's also, if you're thinking about data, that data is not going to be very useful. And so I think that it's sort of the age-old question of any kind of digital platform, of trying to increase the stickiness factor, if you will, right, so that the more folks use these new kind of platforms that live outside of the usual education world, that they're actually going to stick and hang around, so that we can actually learn more from them as they're learning from the platforms. So, thank you. Anne, this is going to be a tough one.
I think what was being asked before,
Go.
and it may not be a Safe Insights issue, but if you think about black taxi cabs in London,
Yep.
versus Uber drivers, you don't have to learn the map, right? Or the radiologists now are being assisted by AI. Is there not a need to try and understand what we need to help students learn versus what the tools can do for us? And in addition to that, I have seen my children not understand ideas of magnitude, where I grew up on a slide rule and you could really understand, exponential issues. So how are you thinking about that, making sure there's somewhat of a core understanding, but not in fact dwelling on, constantly understanding how to do the square root or do the x to the 9th type of thing? Thanks.
Well, this is a great question. Thanks for clarifying. I will just say this is a very difficult question, because it's also it also comes down to what we value in the human mind, right? And what we value in what kind of what we value and how we value what humans bring to our world, right? And I don't know if I have a really good answer. I would just definitely agree that, for example, I'll just add to yours when you talk about taxi cabs. I don't have my cell phone up here with me, but folks aren't able to look at a map and walk around in a city anymore, right? Because it's just Google Maps, right? Or Apple Maps just basically has eroded our capabilities. And so I think maybe I'll just kind of turn your question slightly the other way, and that maybe we need to think carefully about tools that we make available to our students, like inbounds to use, and which are out of bounds to use in some very careful way in order to promote certain, learning that we think is really, really important, right? So it really could be that, there are, we go back, 40 years, that there really are places in the curriculum where you really want students to put away they should put away the calculator, right? For this particular hour of thinking about something related to algebra, because, learning experts have figured out that they're actually going to, it's not about the calculation, right? It's about some higher level thing that we really want them to learn, and that they're going to take away, and the takeaway with them, for like forever, that they're going to have as a skill that will be augmented by a calculator. But if you didn't take it away for that hour, they're never going to develop that skill. So I'm kind of just skirting around your point, but I say this is a massive, it's a really, really big question. But it's and like I said, it's only getting worse, right? As AI picks up more and more skills, right? It's only getting worse, and so to me, it's almost like a philosophical kind of question. So hopefully that just helps a bit.
Thanks. So we should move on to the next speaker. Richard will be around during the breaks if people have questions and want to follow up.
Thank you.
Thanks again.
Thank you.